Alright, we discussed OSI model, and we are in the section where we will dive into some of the most known networking protocols. But before we do that, let us quickly define what exactly is a network protocol. Well, we can say like this. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. It allows connected devices to communicate with each other regardless of any differences in their internal processes, structure, or design. Now, networking protocols are also a reason why you are communicating with anyone online, and for example, it's also a reason why you are able to watch this course. Now, there are many different protocols and all of them are used for different things. Some key characteristics that protocols have would be rules for data formatting and data transmission, addressing, routing, error handling, and some even include security characteristics. Typically, security is found in newer protocols, as older ones weren't really focused on it before. Now, some of the most common protocols and also the protocols that we will take a look at in the next few lectures would be IP, which is considered the foundation of the internet and is responsible for addressing and routing data packets across network. We also have TCP and UDP, which are referred to connection-oriented and connectionless protocols. We also got HTTP, which is protocol used for transferring web pages and other resources over the World Wide Web. And we got other protocols such as FTP, SSH, DNS, which we will also discuss shortly. But nonetheless, this was just an introduction lecture where we defined what exactly is a network protocol, and now let's dive deeper into most known protocols out there. See you in the next lecture. Let us first talk about TCP/IP. Now, what is that? Well, TCP/IP stands for Transmission Control Protocol / Internet Protocol and is a suite of communication protocols used to interconnect network devices on the internet. Now, TCP/IP specifies how data is exchanged over the internet by providing end-to-end communications that identify how it should be broken into packets, how it should be addressed, transmitted, routed, and received at the destination. TCP/IP requires little central management, and it is designed to make networks reliable with the ability to recover automatically from failure of any device on the network. Now, the two main protocols in the IP suite serve specific functions. TCP defines how applications can create channels of communication across a network, and TCP also handles message segmentation into smaller packets and their reassembly at the destination to ensure data integrity and proper ordering. IP, on the other hand, defines how to address and route each packet to make sure it reaches the right destination. Each gateway computer on the network checks this IP packet to determine where to forward the message. So overall, it is important to note that TCP and IP work together as a part of TCP/IP suite to enable communication over the internet. Now, while TCP manages the communication between applications and ensures data reliability, IP handles the addressing and routing of individual packets to ensure they reach the correct destination. But how does it work exactly? Well, TCP/IP uses the client-server model of communication in which a user or a client or a machine is provided a service, like for example sending a web page, by another computer or a server in the network. TCP/IP follows a layered architecture which helps organize and standardize the various networking protocols and functions required for communication on the internet. That layered architecture actually consists of 4 primary layers, which are application layer, which is the topmost layer. It is responsible for providing network services directly to user applications. It also includes protocols and services like HTTP, FTP, SMTP, POP3, and DNS, which enables applications to interact with the network. We got transport layer, and the transport layer is responsible for end-to-end communication and data flow control. And two of the most well-known transport layer protocols are TCP, or Transmission Control Protocol, which provides reliable, connection-oriented communication. It ensures, once again, data integrity, sequencing, and error recovery. It's used for applications that require data to be delivered accurately and in the correct order, such as, for example, web browsing and email. And we also got User Datagram Protocol, or UDP, which is a connectionless, lightweight protocol. It provides faster, best effort communication without the guarantee of reliability provided by TCP. Now, UDP is often used for real-time applications like video streaming and online gaming. Next up, we got the network layer, also called the internet layer, which deals with packets and connects independent networks to transport the packets across network boundaries. And last, we have the physical layer, also known as the network interface layer or data link layer, which consists of protocols that operate on a link, which is the network component that interconnects nodes or hosts in the network. Now, a protocol in this lowest layer would, for example, be Ethernet for local area networks. Alright, those would be some basic stuff that you should know about TCP IP structure. Always make sure to be familiar with the OSI model and the TCP IP model. Now that we got this out of the way, let us talk about some specific protocols, starting with HTTP in the next lecture. HTTP is the foundation of data communication on the World Wide Web. It is a stateless application layer protocol that governs the transfer of data and resources such as web pages between a client, typically a web browser, and a web server. Now, HTTP stands for Hypertext Transfer Protocol. Most information that is sent over the internet, including website content and API calls, uses the HTTP protocol. There are two main kinds of HTTP messages. There are requests and responses. So let's define what are requests and what are responses. Now, HTTP requests are generated by a user's browser as the user interacts with web properties. For example, if a user clicks on a hyperlink, the browser will send a series of HTTP GET requests for the content that appears on that page. These HTTP requests all go to either an origin server or proxy caching server, and that server will generate an HTTP response. HTTP responses are simply just answers to HTTP requests. This response contains the requested content, which would be HTML code, images, or data, along with status information, headers, and other details. Now, one thing to note is that HTTP by default uses port 80. It is unencrypted, which means that it operates over plain text and that it is stateless, meaning each request-response pair is independent. The server does not retain any information about past requests from the same client. But if you're wondering how is traffic being unencrypted and in plain text secure, well, it isn't. It isn't secure at all. That is why we have HTTPS. Now, HTTPS is HTTP with encryption and verification. The only difference between these two is that HTTPS uses TLS or SSL to encrypt normal HTTP requests and responses and to digitally sign those requests and responses. As a result, HTTPS is far more secure than HTTP. A website that uses HTTP has HTTP in its URL, while a website that uses HTTPS has HTTPS in its URL. Now, HTTPS also uses port 443, which is another important thing to remember, and many of your social media websites or banking websites will be using HTTPS. At least they should be. If they are not, well, then there is a security issue. So these would be some of the basic things regarding HTTP and HTTPS. The most important thing to take away from this is that HTTP is unencrypted and HTTPS is encrypted as well as secure, while HTTP is not secure and it is data being transferred in plain text, which can easily be readable by an attacker. Also, HTTP uses port 80 and HTTPS uses port 443. Now, I encourage you to research more about these two protocols. They are important and you want to know more about them, so feel free to research about HTTP and HTTPS on your own. FTP, or File Transfer Protocol, is a standard network protocol used for the transfer of files from one host to another over a TCP-based network, such as the Internet. Now, FTP works by opening two connections that link the computers trying to communicate with one another. One connection is designated for the commands and replies that get sent between the two clients, and the other channel handles the transfer of data. Now, the protocol provides a way to list directories, upload files to the server, as well as download files from the server. It is widely used for tasks such as website maintenance, file distribution, and remote server administration. FTP interactions typically involve two key components. Client, and the client software is used to initiate connections to the FTP server, issue commands, and transfer files, and common FTP clients include FileZilla, WinSCP, and command line tools like FTP on Unix-like systems. And we also have the FTP server, which has the FTP software that runs on a remote machine and handles client connections, interprets commands, and manages file access. Now, popular FTP server software includes ProFTPD, VSFTPD, and FileZilla Server. Besides the key components, which are client and server, FTP also has two main modes. We have active mode. In active mode, the client initiates the connection for data transfer. The server connects back to the client to send or receive data. It's also important to know that active mode can encounter issues with firewalls and network address translation devices. The passive mode, however, is when the server initiates the data connection by listening on a specific port. The client connects to the server's port to send or receive data. And passive mode is more firewall friendly and is often the preferred choice for most modern FTP connections. Now, even though FTP is a widely known protocol and it exists for quite a long time, unfortunately FTP transmits data in plain text, which poses security risks. To address this concern, several secure FTP variants have been developed, such as FTPS, which stands for FTP Secure, and FTPS adds SSL and TLS encryption to FTP, which secures data transmission. It can operate in two modes, which are explicit and implicit. Now we also have SFTP, which is SSH File Transfer Protocol, and SFTP is a subsystem of SSH and provides secure file transfer over SSH connections. It is not, however, related to traditional FTP and FTPS. Now, despite its age, FTP remains a widely used protocol, especially in scenarios where simple file transfers are needed. However, security concerns have led to the adoption of these more secure protocols like SFTP and FTPS in situations where data privacy and protection are necessary. Now, in summary, FTP is a fundamental protocol for file transfer on computer networks, and its secure variants have evolved to address security concerns. All the users and administrators should choose the appropriate FTP variant based on their security requirements and network environment. Welcome back. DNS. Most of you have heard about DNS, right? It stands for Domain Name System, and it is a crucial component in your day-to-day website browsing. The most simple explanation of DNS is that it maps domain names to IP addresses. So, for example, without DNS, you would have to manually type IP address of each website that you visit instead of the actual domains. So instead of typing facebook.com in your browser, you would have to type 31.13.84.36, for example. Okay, you get the point. Now, DNS has several records, and we should be familiar with all of them. We have A records, which are IPv4 addresses or IPv4 hosts. We have the AAAA or Quad A records, which are IPv6 hosts. A CNAME or a canonical name is a type of DNS record that is used to create an alias for another domain or subdomain. We have MX records, and a DNS mail exchange MX record directs email to a mail server. A DNS SRV record specifies a port within a server for certain services, and we have SPF records, which are TXT files that DNS uses to stop the unwanted email traffic and to check if the email truly came from the domain from which it says it came. And we also have DMARC record, which is also a TXT file used by ISP to stop unwanted or phishing emails. Okay, so we know which DNS records exists, but how exactly does the whole process of finding an IP of a domain exactly work? Well, let's draw it here. As you can see, it is not a straightforward process. So let's go from the beginning. Let's say device A wants to search for a domain. First thing that's being checked are something called DNS cache. Now, DNS cache will typically store recently searched domains and their results. It does so for faster response next time that you search for that exact domain. If DNS cache is empty, it will check inside the hosts file. Now, hosts file is a file where you can write entries for certain domains, and this can be to either have quicker response time, or in case you do not want someone else to know about that entry, you can write it inside a host file because that file is stored on a host machine. In case both DNS cache and hosts files are empty, then the request is sent to the DNS server. When a DNS server is unable to resolve a hostname using its own cache and zone files, it will typically forward the request to other DNS servers that are higher in the hierarchy of the domain name system. This process is called recursion. If the result is found, it will typically get stored inside DNS cache for the next use, and if it's not found, the request will fail and you will not load the web page. Okay, so that is how searching for a domain and getting the web page back exactly works. But this is a security course, right? So let's also focus on DNS security. Let's start off by mentioning most common attack on DNS, and that is DNS poisoning. DNS poisoning is an attack where for certain domain, incorrect IP address is given, which can lead to a fake website. Now, poisoning can be done by injecting the record for that domain into any of the steps that we talked about on the previous slide. You can have DNS cache poisoning when the malicious record is injected in the DNS cache, which is first thing device checks once searching for a domain. So when that happens, even if you type the correct domain in the browser search bar, you will be led to the fake web page because that's what your DNS cache entry has. You could also poison the hosts file. However, in this case, if DNS cache has entry, then you won't even get to checking the hosts file, so you will still load the correct web page. If DNS cache does not have that entry, then the hosts file poisoning will work and you will once again go to the fake website. Now, besides DNS poisoning, DNS can be a target of several other attacks, which are DNS hijacking, DDoS attacks, or DNS amplification. Now that we know which attacks exist, we can conclude that DNS is not that secure on its own, right? Well, to increase our security, we can use DNSSEC. And DNSSEC strengthens authentication in DNS using digital signatures based on public key cryptography. Each DNS record is digitally signed, which creates something called RR signature record that can prevent certain attacks since it provides some type of integrity for the records and the results that you get. Now, DNS creates the RR signature record for each host. And another DNS security feature that you can have is something called DNS sinkhole. Now, DNS sinkhole can provide false information to the attacker, or it can forward the malicious requests to the honeypot, which will notify the IT team and keep the network safe. DNS sinkhole can also be used if you want to block certain types of content within the network, which can be done by leading the request for a certain domain to a non-existent IP address, resulting in request fail. So generally, DNS sinkhole is used to block both unwanted traffic and malicious traffic. Alright, that would be about it regarding DNS. Make sure to remember how DNS works, as well as what DNS records are and types of DNS attacks. And be familiar with the security solutions that we talked about when it comes to DNS. Now, in the next lecture, let's talk a little bit about IP addresses. Alright, SSH, which stands for Secure Shell, is a widely used network protocol that provides a secure way to access and manage remote servers and devices over an unsecured network. Now, it was developed in the 1990s as a replacement for less secure remote access protocols like Telnet. In the meantime, SSH has become an integral part of the modern computing landscape, offering strong encryption and authentication mechanisms to protect data and communication. Some of the key characteristics of SSH would include things like authentication, since SSH employs a robust authentication system to verify the identity of users and hosts. Typically, users are required to provide a username and password, or, for added security, an SSH key pair. Now, SSH keys consist of a public key, which is stored on the server, and private key, which is stored on the client. This asymmetric key-based authentication is considered highly secure and less vulnerable to brute force attacks. Now, secure communication is another good characteristic of SSH, since SSH establishes secure communication channels between the client and server. This allows for not only remote shell access, which is command line interface access, but also secure file transfers and tunneling for other network services like web browsing and database access. Port forwarding and tunneling are valuable features that enable the secure use of various applications over an SSH connection. And last characteristics that we want to talk about is portability. SSH is available for various operating systems, including Linux, macOS, Windows, and more. This cross-platform support makes it a versatile choice for administrators and developers working with different systems. Some of the use cases of SSH would be to have secure shell sessions, tunneling, secure file transfers, which is with SFTP and SCP, and remote server administration. Alright, those would be some of the basic things that you want to know about SSH. So we discussed most common networking protocols that you should know the basics for, such as HTTP, FTP, SSH, DNS, TCP, and UDP, as well as we discussed about OSI model and TCP/IP model. Now in this lecture, we will just mention some other protocols out there which you might encounter or hear about, so we won't really be diving into the details about these protocols like we did with others. Okay, so besides the protocols that we already talked about, here are the ones that we should also remember. We have SMTP, which is Simple Mail Transfer Protocol, and SMTP is used for sending and receiving email messages between email servers. It handles the sending of outgoing emails from the sender's email client to the recipient's email server. We also have POP3, which is an email retrieval protocol that allows users to download their email from a mail server to their local devices. It is commonly used to retrieve emails and store them on the client side. And IMAP is another email protocol for retrieving and managing email messages. Now, unlike POP3, IMAP allows users to view and manage email messages on the server without downloading them, which makes it suitable for multi-device email access. Besides these protocols for emails, we have NTP, which is Network Time Protocol, and NTP is utilized to synchronize the time on computer systems within a network. Accurate time synchronization is crucial for various network functions and security measures. ICMP, or Internet Control Message Protocol, is responsible for error reporting and diagnostics in IP networks. It is commonly used with a tool that we already talked about, which is the ping command, which tests network connectivity. Alright, that would be enough about protocols, so now we know what exactly computers do over the network and how do they achieve things, whether that being loading a web page or connecting to a different computer or transferring files and downloading emails. It is all being done with different protocols. Now, there are a bunch of other protocols besides the ones that we talked about in this section, so feel free to research more about different protocols out there. Now that we got that out of the way, let us see a new update as to how the network functions. Okay, so here we are with our previous update of a network. We already have this simple network with computers, routers, switches, and server, and we already know that each of these devices have their own IP and MAC address. But before, we didn't have the whole map. We didn't know how exactly these devices communicate or how do they exchange information. Now we know that they do so with the help of protocols. So each of these devices do their tasks with the help of protocols. For example, let's say that device A wants to load a web page which is hosted on the server. This will be done, as you already know, with the help of HTTP or HTTPS as well as DNS protocol if the web server is not in our network. But in this case, the web server is in our network, so we could access it with its local IP address and load the web page. We can also imagine that device B wants to, for example, enter and manage command line shell from device A. Now, how could it do that? Well, with the help of SSH, for example. So we get the full picture now. We know what common devices are inside of a normal network. We know how they are identified, which is with their IP and MAC addresses. And now we know how do they do their tasks, which is with the help of various different protocols. This is a basic understanding of how a network works. But that was the point of this mini course, right? To get the absolute beginners to understand how a network works in a simple way. But one thing is missing that we still haven't discussed, and that is network security. We now know how network works and how devices inside the network communicate, but we shouldn't leave the security aspect out, especially because I'm mainly a security instructor. So in the next section, let us briefly discuss about different types of network threats and protection mechanisms. Welcome back. Now that we got a full picture of how network looks like and how it works, it is time we talk about another important aspect, which is network security. Now, before, network security was not considered, and that is why we have lots of old protocols which are now vulnerable to various different attacks. Remember when we talked about HTTP and HTTPS? Do you remember what was the difference between these two? Well, HTTP is unencrypted, or simply put, it is traffic being transferred in plain text. This is a security issue, as let's say, for example, you have a website that you want to log into with your account. If the website uses HTTP and you input your username and password, that traffic, including your username and password, will be transferred in plain text. This is vulnerable to the attack called man-in-the-middle attack, or MITM, which is one of the most common network attacks out there. It is when the attacker intercepts the connection between devices on the network so that all the traffic goes through the attacker's machine. Logically, if the traffic is going through the attacker's machine in plain text, well, then the attacker can simply read your username and password and gain access to your account on that website. The attacker performs this type of the attack by performing something called ARP spoofing. We mentioned before what ARP protocol is. ARP stands for Address Resolution Protocol, and it is used for IP to MAC address resolution. The attacker essentially sends ARP response to all the devices on the network, telling them that he is the router and sending them his own IP address. This response tricks other devices on the network to then forward their packets to the attacker, thinking that the attacker is the real router. The attacker, once receiving packets from other devices, then forwards those packets to the real router and establishes a man-in-the-middle connection like that. HTTPS prevents this, as it makes the traffic encrypted, therefore useless for the attacker, as the attacker cannot read them even if the connection is intercepted. Now, another common network attack that you most likely have heard about are DDoS or Distributed Denial of Service attacks. DDoS attacks floods a network or website with a massive volume of traffic, overwhelming the resources and causing it to become unavailable to legitimate users. Attackers often use botnets to launch these attacks, and what a botnet is simply a number of devices infected by the attacker, which are then used for various different attacks, including launching DDoS attacks. These devices are also called zombies. Now, DDoS attacks can also be used on various different services to make them unreachable or unusable, which is simply done by just flooding the traffic and making it slow to the point of it crashing. Another threat on a network, besides the two that we already mentioned, can be a malware or a worm. Now, malware is typically used to infect an endpoint device such as a laptop or PC, but these programs can also be designed to first infiltrate a network and then infect the device on that specific network. Worms are self-replicating malware that can spread across network without user interaction. They can consume network resources and deliver payloads such as viruses or other malware. Now, these would be the most common threats on a network. Of course, there are others, but this isn't a security course. We just wanted to be introduced with most common attacks that can happen. In the next lecture, we will discuss the most basic methods that you can use to protect yourself against these type of the attacks. See you in the next lecture. Okay, let's talk about protection mechanisms against different network attacks. So there are two main types of security protection mechanisms that every machine should have, and that is antivirus software and firewall enabled. Now, in this lecture, we're going to take a look at simple firewall configuration in Windows, as well as Windows Defender and how it works. Okay, so to open the Windows firewall, we can navigate right here and type Windows Defender Firewall. We should have this option available right here, and if I click on it, it should open the firewall settings, and here they are. Let me just enlarge this a little bit so we can see everything better, and here are the firewall settings. So to enter the advanced settings, we want to click on this option right here, and this will require administrator password. I don't personally have administrator password enabled here, so it automatically opened this firewall settings, but for you, you might need to input the admin password first. Once you do that, this window will open up, and here we have the default Windows firewall, and we already mentioned before that firewalls can be used to set up filters or rules that are used to filter certain traffic. Here we can see that we have two types of rules, which are inbound and outbound rules. Now, inbound rules are for the incoming connections, while outbound rules are for the connections going from our machine. Now, by default, inbound connections are blocked on a regular Windows PC, while outbound connections are allowed, and we can see that by double-clicking on Windows Defender Firewall right here and clicking on the profile settings. So if I click Windows Defender Firewall Properties, it will open this small window where I will see three different profiles, which are domain profile, private profile, and public profile. Now, domain profile, it says right here, is behavior for when a computer is connected to its corporate domain. Private profile is behavior for when a computer is connected to a private network location, and public profile is behavior for when a computer is connected to a public network location. And here we can see the inbound and outbound settings for all three profiles. We can see by default, inbound connections are all blocked, and outbound or outgoing connections are all allowed. This is something that you can change if you wish, but these are the default settings. Now, if we go back right here, where we can once again see our inbound and outbound rules, this is the place where you want to set up your filters and rules. In a real world, administrators would customize the profiles using rules and filters so that they can work with user apps or other types of software. For example, an administrator or user may choose to add a rule to accommodate a program, to open a port or protocol, or allow a predefined type of traffic. Let's see how we can set our own rules. So if we click, for example, on inbound rules, we can click on this option that says new rule. It will open this window where we will have different types of settings or different types of steps that we have to go through for our rule to start working. So the first thing is, what type of rule would you want to create? Is it for a program? Is it for a port? Is it predefined or a custom rule? So let's say that we want to make a rule for a port. We want to set a rule that controls connections for a TCP or UDP port. We click on here, click on next. We choose whether the port is TCP. So for example, let's say the port is indeed TCP, and instead of setting all local ports, which will affect all the ports, want to specify a single port, and in this particular case, let's say it's port 7777. We click on next, and here we decide what we want to do with the rule. Do we want to allow the connection? Do we want to allow the connection if it's secure? And here we can customize this rule. Or do we want to block all the connections on this port? Let's say we want to block the connection. We click on next. We click on which profile does this apply, so you can apply it only on public profiles or on public networks, or you can apply it to all three, or just pick whichever one you want. So for this specific example, let's say that I want to apply this rule for all three domains. I click on next, and here I input the name. Let's say the name is test123. Of course, you would not have named it like this in a real world, but just for the purposes of this example, I'll name it test123, and I'll click on finish. And here is my rule, test123, blocking the traffic, all profiles, it is enabled. And here it says, if we scroll, which type of action it is block type of action. We want to block the traffic, any program, any local address, and any remote address. All right, so that would be it about the basic rule configuration in the Windows Firewall. You can play around with this a little bit and create new rules. But next thing that I want to show you, which is also inside the Windows system, is Windows Defender. Here it is, Windows Security. And both of these programs that we showed, including Windows Firewall and Windows Defender, are useful for protection against the threats that we mentioned in the last lecture. So worms and malwares, Windows Firewall and Windows Defender both are useful at protecting against both of them. Also, some types of exploits can also be stopped by Windows Defender, and you can filter different traffic with the Windows Firewall, as we already saw, so you can only filter the traffic that you want to see. Now, Windows Defender, on the other hand, is a lot simpler, so we just click on Virus and Threat Protection, and here you can scan your system for any malware or virus that is currently on your machine. You have different scan options down here, so we have Quick Scan, we have Full Scan, Custom Scan, and Microsoft Defender Antivirus Scan, and all their descriptions are down below. The quick scan lasts about 10 to 15 minutes, while full scan can be hours and hours long depending on the amount of files that you have on your system. You also have account protection, you have firewall network protection, which we already talked about, you have app and browser protection. Here is also the exploit protection, which I mentioned a few seconds ago, device security, device performance and health, and that will be pretty much about it. Also down here you have protection histories, so if you have previous Defender scans which found something, it should be displayed right here, and any potential security breaches or security concerns will be displayed right here. So it is rather simple to use. You just click on Virus Threat Protection and you scan the device for potential threats. Alright, so these two will help a lot to mitigate some of the threats that we talked about and some of the most common network attacks. So once again, thank you for watching, and I will see you in the next lecture, which is last lecture, where we put together the final image of our simple network. See you in the next lecture.